Put stopwatch here so I don't talk too long. Copy that off Josh. Here we go. Start. Everyone knows, and we've alluded to them today, there are so many schemes for expressing yourself in medicine, and they've come about for some for good reasons, because there was no other way to express, some just because there was some institution that wanted its own scheme. If it has a large budget, the National Cancer Institute gets to define all its own stuff, no matter what it seems. And I'm, by the way, a neophyte in this whole thing. It just occurred to me, kind of dropping in from Mars, why is this thing the same as this thing? Why are both these parties seemingly doing the same work? And you realize it's more to do with institutional momentum than it has to do with knowledge, per se. But just looking at 5 simple schemes, so we're not talking about the NCI thesaurus here, which is a whole other ball of wax. We're not talking about DRGs or anything else. 5 simple schemes. If you look at SNOMED, the HDD from 3M, which Sam was instrumental in getting the underlying software defined. This is the open part of the HDD that 3M put out. So everything in the DoD, for instance, if you're coding up blood pressures or whatever in the DoD, you're using NSIDs from 3M. You're not using any of the other standard schemes. ICD-9, which everyone's using until 10. The VA schemes in general, because the VA uses its own schemes, and then RX norm. So you have a collection of things. If you add them all up, you get a number close to the expressiveness of William Shakespeare. So William Shakespeare used nearly 900,000. We're up to about 745,000. Frankly, if we just added in one more, we'd be up with Shakespeare. But in truth, of course, we're nothing like as expressive as William Shakespeare. In truth, when you start looking at it, there's an enormous amount of redundancy between all of these schemes. So for instance, you can talk about hypertension in SNOMED, you can talk about hypertension in the HDD, you can talk about hypertension in, this is a live server I'm just clicking against, and in the VA they like hypertension so much you can talk about it in the lexicon, you can talk about it in their NDFRT, in their national, oh I've just clicked on the wrong thing, in the NDFRT. So in some cases even one organization has 2 different ways of representing the same information or the same concept simply because they have different branches of software that they use. And those 2 data sets within that organization don't merge because they're using completely different identifiers for those same things. Of course, when you get into something like drugs, you're all over the place. The VA has acetaminophen, lots of variations. SNOMED does it, RX norm does it, HDD does it, so the NSID for acetaminophen in the DoD is going to be that long number at the end, which will be different than the RX norm code. There's no RX norm in all those DoD databases. So what happens is someone comes along after everyone's established all this stuff in their own schemes, and they say, I need to export and normalize that data. And there's a big integration project. When in reality, everyone's saying the same thing. There shouldn't be any big integration project. These things at the simple level, not where Stan was talking about the more complex coordination. At a simple level, they should all just work together. Now, if you look at it, there is some coordination effort. If you look at, for example, in the VA, they just talk about blood pressures. In the DoD, they'll talk about a blood pressure, and they'll coordinate it with sitting or standing or whatever. So you're not allowed to just say blood pressure in the DoD. And so you get into the coordination issue. But again, that's totally mappable or something that you should be able to take care of within one SNOMED scheme. If we reduce the redundancy, we start getting to SNOMED sort of levels, about 300,000 concepts. We're not up at expressiveness of William Shakespeare, we're way down here. And if we can remove the obvious redundancies, we will take care of a lot of the stuff when Josh was talking about how to make my data presentable. We'll get rid of a lot of that stuff right off the bat, and then we can concentrate on the more complicated things Stan was talking about. One thing that's really egregious, cloning. This is where somebody wants to make up a scheme and they say, I'm going to take stuff that was defined by somebody else, but I'm going to stop using their codes and make up my own. So the national drug file from the VA is MESH from PubMed for diagnoses. Right? Their own VA drug file, which is VUIDs, and they gave totally new names to them. And that is the US national standard for drug and drug-drug interaction data that's put out, and it's on the FDA's website. All they did was take other people's stuff and rename it. But now they have the typical thing when you do that. If you're a coder, you'll know it's forking. You immediately get out of date out of 6 months, because this guy goes along, and you don't go along, and now suddenly you are using old things that he's deprecated, and you don't get his new stuff. And somehow somebody comes along in about 2 years and says, we are going to put out an RFI for the mapping project between the NDFRT and MESH. And that is now a government contract. right? And that is basically how this sort of nonsense, the cloning particularly, leads to contracts. If in the DoD everything uses 3M NSYNCs, 3M has put out a great thing. We're making all of our coding schemes freely available for the whole world to use. That's a wonderful thing. But of those coding systems, and they claim back in February they have 215,000 concepts. Of those, over 80% of them are just clones of other people's stuff. 3M came along, they took an ICD-9 and gave it an NSYNC. And now in the DoD's database, it's an NSYNC, it's not the I-9. But if the I-9 changes, now the DoD has a mapping task. They haven't solved anything, they actually make it more difficult. And what it leads to is, and I know I'm going to run out of time, what it leads to is the issue that we concentrate then in coding on how do you match stuff. Oh, can we match this scheme to that scheme? Instead of looking at how detailed our definitions of stuff is. So for example, take something like, you've got irritable bowel syndrome. I'm back to diarrhea again. You've got irritable bowel syndrome just means you've got diarrhea and I don't know why. That's all it means. It's idiopathic, I don't know why you've got it. You're told you have esophageal cancer. They can measure that. You've got staging on the cancer. If you're HER2 positive, you could take Herceptin, and if you're in the 1/3 of cases where you will react to that, well, that's really a magic drug in that particular case. If you're not, you're really unfortunate. The two things are completely different clinically in terms of how precise you can be. And I know I'm going into danger turf here because the doctors here and they can tell me. But look at it like this for a second. Here is SNOMED irritable bowel syndrome. And this is SCOS, by the way, if you're wondering. So there's lots of names. You'll see it's a disorder of somewhere. It has a finding site, and there's lots of specializations. So I'm a margin. I come down and I say, do those human beings know anything about irritable bowel syndrome or esophageal cancer? Do they know more about one than the other? In SNOMED, if I only looked at SNOMED, I'd say, you know what? I think they know the same amount about both of them. Both of them are telling you it's a structure, there's something wrong. If you actually go into the specializations of the irritable bowel, you'll find that there's some designations of some of the side effects. Effectively, the total modeling in SNOMED is basically the same for both. And yet, the significance of one is dramatically different than the other. And one of the reasons for that, this is conjecture, I think, is that we spend so much time mapping between things that are completely the same, because institutionally we keep redefining the same stuff over and over. We should actually be concentrating on making sure that esophageal cancer is a lot better mapped and modeled than something is made up as IBS. Last thing, just one, in standard formats, the last thing, and this gets into something else we've talked about today, which is in exposure of information, where RDF comes into play. And Emery and I, we've been in multiple projects, we've had to deal with multiple terminologies from different places. Everyone has their own release format. SNOMED has two, RF1, RF2. The UMLS has RRF, Borax norm is a subset of RRF. The ICD-9 used to be great, it was really only PDFs. So everyone has their own release format, and you then have work to do to get them into into a form that you can use. And in fact, a lot of commercial organizations would sell that to hospitals. We'll get it into the form, you can use it. If you take everything into, SCOS is an international standard that simply allows you to express what's in these different schemes in their native forms, and get it all into that one form, you can now start doing the type of mashups that Josh was showing, and the type of mapping between things and analysis I was showing about cloning and other things. And you get rid of that, what was the expression you used? About or it was an exposure thing to do with, there was a mismatch between once you get beyond the syntax into across that barrier. Anyway, that's what SCOS will give you on terminologies. Unfortunately, nobody natively publishes in that right now. Anyway, that's it. Thank you.
Question or two. Okay, question or two for Conor while I'm switching here.